Take anything near you, break it down far enough, and you reach atoms. There are only about 90 kinds that occur naturally on Earth. One of them builds more than all the others put together. Every particle here is the same element. Carbon. 6 protons, and usually 6 neutrons, packed into a nucleus. That nucleus holds almost all of the atom's mass, in almost none of its room. If the nucleus were a golf ball, the atom around it would be more than a kilometre across. Because the rest is electrons, 6 of them, and they are not dots on little orbits. They are probabilities, a cloud of everywhere the electron might be. 2 of them sit close in, tight against the nucleus. The other 4 sit further out, in a shell with room for 8. 4 filled, 4 empty. That is the whole story. So 4 empty places and 4 partners to fill them. The only question left is where they go. All of that becomes a single grey sphere, a ball and stick model. The sphere is drawn well under the atom's true size, so you can see what joins them. An atom with 4 vacancies will take 4 partners, and it will hold them as far apart as it can get them. A tetrahedron at 109.5 degrees. One thing before we go further. Those spheres are drawn small, so you can see the bonds between them. At their real size, they touch. That is how much of the space an atom actually fills. Give every carbon atom 4 neighbours on those angles, and the pattern has no choice. It repeats in 3 dimensions, and it does not stop. 154 picometers between each atom, over and over, without a flaw. Push on it, and there is nowhere for anything to go. Every atom is braced by 4 others, and each of those by 4 more. That is diamond, the hardest natural substance on Earth, and it is nothing but this one shape repeated. It is also perfectly clear, and that comes from the same arrangement. Every electron is locked into a bond. There are none left loose to absorb light, so light simply passes through. Now take the same atom and spend only 3 of its 4 bonds. 3 partners spread out flat at 120 degrees, and the atoms fall into hexagons. A sheet exactly 1 atom thick. Inside that sheet, the bonds are shorter and stronger than diamonds. 142 picometers. But stack the sheets and there is almost nothing holding one to the next. 335 picometers of empty space and the faintest attraction across it. So they slide. Drag them over paper and they come away in layers, a few atoms at a time. That is graphite. That is a pencil line. And the 4th electron, the one that never found a bond, is still there. It drifts across the whole sheet, free to move. That is why graphite carries a current and diamond will not. Same atom, 1 spare electron. It is why graphite is black too. Those loose electrons absorb light at every wavelength, where diamond let it straight through. Now lift a single sheet away from the stack, 1 atom thick. You could stack 300,000 of them and still not match a sheet of paper. This is graphene, and along its plane it is the strongest material ever measured. Around 130 gigapascals, roughly 200 times steel. Same atom, same 4 bonds. Only the arrangement changed. And those same 4 bonds are the reason you exist. Carbon chains with itself in a way almost nothing else does. Rings, branches, chains thousands of atoms long, and all of it stable at the temperature you happen to live at. Sugars, proteins, DNA, every one of them is a carbon frame with other things hung off it. There are millions of known carbon compounds, more than every other element put together. The hardest thing on Earth, the mark on your page, and you. Which leaves one question. If they really are the same atom, can you turn one into the other? You can. Put graphite between two anvils and start pressing. At first, the sheets just move closer together. The space between them is mostly empty, and empty space gives. Then they start to buckle. They cannot stay flat and keep getting closer, so they bend. Past about 5 gigapascals, at 1500 degrees, the bonds inside the sheets begin to fail. First where the bending is worst, and then every atom reaches out and finds a fourth partner. The sheets collapse into a cage. Nothing was added, nothing was taken away. The same atoms, holding each other differently. Left to grow with nothing crowding it, diamond takes an 8-sided form, an octahedron. We make diamond like this by the ton, and almost none of it ever goes near jewellery. It goes onto saw blades and drill bits, because nothing else keeps an edge as long. And it goes underneath processor chips, because diamond moves heat better than any metal, about 5 times better than copper. Graphite goes into the anode of very nearly every lithium battery you own, and into the cores of nuclear reactors, where it slows neutrons down. Graphene is going into composites, sensors, and electrodes we are still learning how to build. And carbon fibre, which is these same sheets drawn out long and wound tight, is what holds a rocket together. 1 atom, 4 bonds. Everything depends on how you arrange them.
Thanks for watching. If you enjoyed this, please like and subscribe.